Good morning. This is your stats sensei, Mr. Spensei, and this is going to be a warm up and it's going to be an introduction to the T distribution and provide a bunch of information about the T distribution. We're going to go out of order instead of starting with when should we use the T distribution. We're going to briefly compare and contrast the normal distribution and the T distribution. So let's start off with the T distribution. First off, the T distribution is like the normal in that the T distribution is mound shaped and it's also centered on zero. All right. So the T distribution is mound shaped, centered on zero. It's symmetric, all those things. So this is what the T distribution looks like. Now, the T distribution is fatter, so it's wider than the normal. And has more area in the tails. So when I compare it, to the normal, the T distribution has more area out here, and the normal distribution is closer to the center. So if this were a T distribution, the normal distribution would look something like this: taller and skinnier and closer, more data closer to zero. But they're both symmetric and mound shape. Now, something else about the T, there's a different T distribution for every sample size. So for every single sample size, there's a different T distribution. So we like to talk about that as for every degree of freedom. And degree of freedom is n-1. So basically, with the normal distribution, we had the empirical rule, and the empirical rule for the normal was plus or minus 60, plus or minus 1 is 68%, plus or minus 2 was 95%, and plus or minus 3 was 99.7%, and that was true for all normal curves. Well, that's not the case for the T. The T has a different distribution for every single sample size. So different distribution for every sample size. Now the formulas are almost exactly the same. The formula for the T is just simply T equals X bar minus mu S divided by the square root of N. Well, when I compare that to the Z is X bar minus mu standard deviation of the population divided by the square root of N. So the only difference between the two is the T has the sample standard deviation and the Z has the population standard deviation. All right. And so that actually lets me know when I need to use the T. So the T uses the sample standard deviation. The normal uses the population standard deviation. All right, so that's the difference between the major difference between the two. The T has more area in the tails, and there's a different percentage for every single degree of freedom or every single sample size, whereas all Z distributions are plus or minus 1 is 68, plus or minus 2 is 95, plus or minus 3 is 99.7. So when should we use the T? Well, our conditions are basically these. Well, first off, we use the T when we use the sample standard deviation. And most of the time, we don't know the population standard deviation. Most of the time, we don't have this. So we're stuck using this, the sample standard deviation. So most of the time, we're going to be using a T. What conditions must be met in order to use the T distribution? Well, like the normal, we have to have a random sample. That never goes away. Everything needs to be random. The N needs to be less than 10%. And the distribution has to be normal. Now, it can be normal in more than one way. Either the distribution is normal or N is greater than 30. All right. So either the distribution is normal or N is greater than 30. But that was exactly the same thing we ran into with the normal distribution. So basically, they're very, very similar. The only differences that, and they're major, is the T distribution uses the standard deviation of the sample. The Z uses the standard deviation of the population. The percentages stay the same for every single normal distribution, regardless what sample it came from. Plus or minus 1 is 68, plus or minus 2 is 95, plus or minus 3 is 99.7. And for the T distribution, there is a different probability for every single sample size or for every single degree of freedom. I hope that helped and look forward to seeing you on the next one. Thank you.